Hello everyone, welcome back to Life with Technologies YouTube channel, and thank you so much for watching this episode. So this is another episode of our Huawei Lab simulation series, and in this episode we will be focusing on how to implement OSPF in the area route summarization on area border routers or the ABRs. So before we dive into this topic, just a kind reminder that if you are watching this episode and you are yet to subscribe to our channel, kindly support us by subscribing to this channel and also sharing with your connections. So we are focusing on how to implement route summarization. And one of the things that you need to understand is why are we implementing route summarization? So route summarization is a very important technique in network engineering. And the objective of doing route summarization is to be able to reduce the size of the routing table and also to implement or to improve on network performance by improving network stability. So you can see that in this topology, we have three areas. We have area 0, we have area 1, and we have area 2. And before you perform route summarization, you need to do proper planning of the IP addressing. So the IP addressing or the IP planning should be contiguous on the network so that it's easy for you to perform route summarization. In this topology, you can see that in area 1, we've used 10.10.10.0/24. In area 2, we will be using these IP addresses 30.30.30.0/24. So this is the subnet that has been assigned for all the nodes in area 2. In area 1, we have also used the same. So we are using 10.10.10.0/24 for all the connection that we want in area 1. So it's very easy to implement route summarization with such kind of IP addressing. So I've mentioned that one of the benefits of implementing route summarization is that we are able to reduce the size of the routing table, because now if you've summarized a route, the specific routes will not be advertised into the area. We only advertise the summary routes that we've configured on the router. We also improve on network performance. So if we have a smaller routing table, it means that the route lookup will be faster, and even when there is an issue in the network, we will have quick network convergence. And in route summarization also improves on network instability, because if we have any single route that is flapping in the network, then there will be no update, because the summary route will continue to be advertised to the other area, and the specific route that are flapping, the flaps will be hidden under that summary route. So you can see that those are the key benefits of route summarization, from reducing the size of the routing table, reducing the number of updates, and also improving on network stability. So in this topology, you can see that we have the three areas, area 0, area 1, and area 2. And we have two ways in which we can implement route summarization in OSPF. The first one is on the ABRs. So remember that the ABR, these are the area border routers that are connecting one area to the backbone area. So we can implement route summarization on the ABRs so that for example, from area 1, we only need to advertise a summary route from area 1 to area 0. Also, from area 2, we only need to advertise a summary route from area 2 to area 0. So on the ABR, we can configure such that we only advertise that summary route from the area 1 and area 2, and we don't advertise the specific routes to the backbone area. Similarly, we can also do the same from area 0. We can configure it to only advertise summary routes to area 1 and also to area 2. Because remember, when you're advertising those specific routes, it's the same logic. You don't need all those specific routes when the destination subnet is the same. So we only need to have the summary route in the backbone area, and then these routers in the backbone area, they will know that for us to reach this subnet, we need to forward the traffic to the ABR. So those are the benefits and the reasons why you need to perform route summarization. And I've also mentioned that when you are performing route summarization, you need to do proper planning for the IP addressing. So the IP addressing should be contiguous, and then it should be very easy for you to implement route summarization. So it starts from the IP planning, and then now it's easy to implement route summarization if you've done a good IP planning in your network. So you see that in this topology, we have different subnets, and these different subnets have been assigned to different areas. So you can see that routers or any connections in area 1, they will be using 10.10.10.0/24. Area 2, we are using 30.30.30.0/24. Then we break them, we subnet them further into /31. So it's very easy to summarize these networks. For example, in area 1 will be 10.10.10.0/24. In area 2, we can just advertise one single summary route of 30.30.30.0/24. So these specific prefixes will not be advertised into OSPF, making it easy and reducing the size of the routing table on our backbone routers. We can also do the reverse from the area 0 to area 1, and makes it easy to improve the network stability of our network. So let me log into these routers, and we've already implemented OSPF. We've configured OSPF. Remember, the focus of this lab is not on OSPF configuration, but just to show you how to implement route summarization. So if we start on R1, if I display OSPF peer brief, you can see that we have peering sessions. We have 2 peering sessions in area 1. We also have 2 peering sessions in area 0. If I display OSPF LSDB, you can see that we have the LSAs. They have been propagated into the different areas, from router LSA to network LSA to summary network LSA. This is type 1, type 2, and type 3 LSAs have been propagated across the network. In R4, we also expect the same. Display OSPF peer brief. This one will give you the adjacency that we have. You see that we have 2 in area 0 and 2 in area 2. On R2, if I display OSPF peer brief, we also expect to find similar output. We have 2 peering adjacencies in area 1. This is to router 1 and router 3. So if I show you the OSPF configuration, display current configuration OSPF, you are able to see that we've created OSPF process 10, we've configured the router ID, which is always a best practice, and then we've advertised these networks into OSPF. So let's start by here. I'll just delete this so that we'll implement it later. So OSPF 10, area 1, I'll undo this command first so that I show you why we need this command. So when I check the routing table for the different routers, starting with R2, if I display IP routing table, you will see that we are getting all these specific routes from different areas. Even when I check on R1, we also expect the same, display IP routing table, because this is the ABR. You can see that we are advertising this /31 IPs into OSPF. On R7, display IP routing table, you can see that we have all these specific routes, /31s for area 1 and area 2. We are getting all these detailed routes from different areas through OSPF. So what we want to do is we only want to advertise a summary route on R1 so that we are not getting these /31s. And we only get a summary routes on R7, and all these /31 should disappear from our routing table. So what we do is we implement on the ABR. Remember, we can implement route summarizations either on ABR or ASBR. So on this router, on R1, if I display these, you can see these are the OSPF configurations. And what I need to do is I'll move to area 1. And once I'm in area 1, I can configure that summary route. So, and the way we do it is use the command ABR summary. So with the ABR summary, you can use a question mark. We specify the IP subnet that we want to summarize. You give the subnet mask 255.255.0, and you can either use the command advertise or the parameter advertise, or you can just leave it the way it is. By default, it will be advertised. If you don't want to advertise it, you use the not advertise. Sometimes you can also specify the cost. So I will just use advertise command. And now, given that I've implemented this route summarization on this router, if I go back to R7 and I display IP routing table, you can see that before we had these three prefixes, they are coming from OSPF 10.10.10.0, 10.10.10.2, and 10.10.10.4, but currently they have all disappeared. We now have 10.10.10.0/24. So we've replaced those three prefixes with just one prefix, and we've reduced the size of the routing table. And if you have so many other prefixes, they will all disappear. They will all just fall under this one prefix. So it makes it easy even to troubleshoot and also to improve on the stability. Because remember, whenever there is any contributing route that is still active on R1, then these routes will be summarized into 10.10.10.0/24. So we want to do the same on R4. So on R4, or if you check on R7, if I display IP routing table, you can see that we are also getting these prefixes, these three, 30.30.30.30.0/31.2/31 and .4/31. So we also don't want these prefixes because we could be having so many of them that are coming from area 2. So we want also to summarize these prefixes so that we only have one prefix that should be coming in, and that prefix will be 30.30.30.0/24. So we do the same on the ABR. So I'll go into the OSPF configuration, OSPF 10, display this to show you the configuration that we have. I need to be in area 2. If I display this, this is what we have. So I need to do ABR summary. And then I specify the prefix, .0, and then advertise. So with this command, we are able to summarize all the prefixes, all those prefixes that fall under this 30.30.30.0/24 will not be advertised to the backbone area, and will only have a summary route. This summary route that we've configured, it will be the one that will be advertised into the backbone area. So when I click enter, maybe I just need to run the same command here. You can see the routing table. Now we expect these three prefixes to disappear, and our network will be much cleaner as compared to before. So let me go to R4, I click enter, then I go back to R7. Once I've applied that command, you can see that we now have only this summary route. We've lost all the specific prefixes that were coming. The /31 have all disappeared, and we only have that summary route that has been advertised into OSPF. So you can see that now the routing table of R7 has reduced. We had so many prefixes. We had all these prefixes. We had 10.10. We had these three coming in as specific prefixes. We had 30.30.30 also coming in, and now we've reduced the size of the routing table to only have the summary route that we've configured, 10.10.10.0/24 and 30.30.30.0/24 are now summary route that have been advertised. So whenever there is any change in this area 2 that is affecting any of the prefixes, /31 prefixes, it will not be propagated into area 0. Similarly, whenever there is any network change in area 1, maybe there is a prefix that has, maybe a link has gone down, that will not be propagated into the backbone or area 0. So we have improved on networks stability. We've also improved on network performance because we have reduced the number of updates that are being advertised in the network. We've reduced the size of the routing table, and that one improves the network performance. So this is how you implement route summarization on the ABRs. Remember, just one command. You need to ABR summary. You specify the ABR summary. You specify the prefix that you want to summarize and advertise into the network, into the backbone area, and then you specify the mask, the subnet mask. And then you can either use the advertise command or you may choose to not use that command. By default, it will be advertised into the backbone area as a summary route. And that one will not impact any connectivity. If you check on this R2, you can see that on R2, we also had these prefixes. And now, if I display the IP routing table, you see that we've also reduced the size of the routing table on this R2. We now have the summary. If I try to ping 30.30.30.1, you can see that we can still reach the other side of the network. We are able to ping the prefixes, the individual IP addresses that have been summarized with that summary route. I can ping 30.30.30.3. I'm able to ping from R6. We can also test connectivity to R2. So I can ping 10.10.10.1. You are able to ping. You can try .4, which is configured on R2, and you can see that we don't have any reachability issues. We've just reduced the size of the routing table by advertising a summary route instead of the specific routes, and this one has helped reduce the size of the routing table on all of the routers in our network. So this is it, guys. I hope you've understood this topic. I hope you've learn something new from this topic on how to implement route summarization, and that's something that we do very often on live networks because we are trying to reduce the size of the routing table, we are trying to improve the network performance, and this is how you do it. Just one command, and this one only focuses on the ABR route summarization. In the next episode, we will demonstrate to you how to implement the ASBR. So sometimes you also have so many prefixes advertised from an external network and you want to summarize those prefixes into a summary route. That one will be done on the ASBR and we will demonstrate it in our next episode. Thank you so much for watching this video, and just a kind reminder again, if you haven't subscribed to our channel, kindly hit that subscribe button, like this video, comment, and also share with your connections. Thank you so much and see you in our next episode. Bye.